Hello, this is our last video about normal distributions, and we are going to talk about how to use our calculator to do a lot of the normal distribution calculations. So we have this example. Assume the heights of 18 to 20, or for women 18 to 24 are approximately normally distributed with a mean, this should be a mean, of 64 inches and a standard deviation of 2.5 inches. So before we do anything, I've got some little pictures of the calculators. Let's pull these up. So if you look in your calculator, you're going to find this menu. You're going to hit the second button, and then you're going to hit VARs. Just above VARs, it says distribution. Okay, and it brings up this menu. To do what we're going to do, you're going to pick the second option, which is normal CDF. And then depending on the addition of your calculator, it might, this is a maybe, it might bring up this. This will allow you to put in your numbers. Now, you can put in your lower number, your upper number, you have your mean, and then your standard deviation. Now, one thing to note is that your calculator, it can't do infinity. So if you ever want to do infinity, you have to put it in like this. So this is using scientific notation. This is the smallest possible number that you can put in. And if you wanted positive infinity, you would do it without the negative. To get the little e, the scientific notation, in case you forgot, you would hit second and then the little comma button. That brings up your e's for your scientific notation. If you don't have this version of the calculator, you don't get this menu, but it'll pop up normal CDF. So here you just put your min, then you have your max, then you have your mean, and then your standard deviation. So then after you punch those things in, it'll give you your answer. So let's do a couple examples here. So the first question, question A, says what percent of women in this age group are taller than 64 inches, taller than 66.5 inches, or shorter than 59 inches? So if we pull up our calculator, you can kind of watch me do this. So taller than 64 inches. So we're going to go second and then VARs, and it brings up the distribution menu, and we want normal CDF. So what percent of women are taller than 64 inches? So that means that my lowest would be 64. My upper, that's when I just put in my big giant number. And here I'll type in my mean. My mean is 64. And then my standard deviation is 2.5. And then hit enter. Then hit enter again. It says 4.99995, which makes sense because the mean is 64. So 0.5. And then taller than 66.5 inches, that should also be maybe a little obvious for you because that's one standard deviation above. But we'll go ahead and punch it in just to see how it works. It'll save your previous information, which is kind of nice. So just switch this 64 to 66.5. All the rest of it stays the same, so just hit enter to go to the next thing. And you get 1.586 and then shorter than 59 inches. So this one's a little different. Go back to your menu. Option 2, this time shorter. So I want to do a negative infinity. So -1, then standard deviation 99. Again, that's just the biggest number we can punch in. And then we are maxing out at 59 inches. Those other two things stay the same. And so you're looking at 0.2275. Or 2.275%. And so that's another way to do it. And a little bit more efficient way than doing z-scores, but some people really like z-scores. If we were to take one random sample of 1,000 women in this age group, how many would we expect in our sample to be below -1.6 z-scores? And what height is this? So we can do a little bit of backtracking. First, need to figure out what height this is. So if I know the z-score is this, and I know that my mean is 64, and I know my standard deviation is 2.5, I can work backwards to figure out what number this should be. So when I multiply both sides by 2.5, I get 4. Then I add 64 over, that would be -4. I add 64 over, I get 60. So a -1.6 z-score is just 60, a height of 60. So I can go to my calculator, and this is actually a different entry. When I know this number, I still need to find the CDF, but then I'll just multiply my answer by 1,000. So after a while, it clears you out. So we'll see. Option 2. So how many do we expect to be below? So negative infinity, maxing out at 60. My mean and standard deviation stayed the same. I'm going to hit enter. And I get 0.5. Or 5%. Which makes sense because it's slightly more than what we were when we were 59 inches. This one doesn't have any infinities. So again, you're just going to punch it in. What percent of women would we expect to be in between those two? So our lower is 61. Our upper is 65.5. All the other numbers stay the same. So we're looking at about 0.6106 or 61.1%. And then this is the interesting one. This one is actually a problem where we work backwards. 90% of women are between the ages of 18 and 24. Are what height are less? And that question might seem a little confusing, so let's draw it. So 90% of the women between 18 and 24. So remember, this doesn't mean anything. This is just our original definition. Are what height or less? So like we want this to be 90%. So to do that, again, we could go to the table and we could try to find 90%. We would definitely be looking on the positive end, but there's another way to do it. There's kind of an opposite operation, and that's this one, option 3. So you would hit second, then you would hit vars, and then option 3 is inv-norm, or the inverted norm. So here you type in your area, which for us will be 90% or 0.9, and then your mean and your standard deviation, you'll paste it in. So you have your percent as a decimal, your mean, and then your standard deviation. And it'll tell you what number it will be. So you don't have to go backwards and find the z-score yourself. Keep in mind that this only works from the left. So it's only finding this percentage. So if you wanted like the middle 90% or something like that, you would have to do something different. So let's punch it in and see what happens. So we're going to go to second vars, and then we are going to go to option 3, inverted norm. Our area is 0.9. Our mean is 64. And our standard deviation is, I forgot what it was, 2.5. Paste that in. 67.2038. So 67.2. So 67.2 is bigger than 90% of people. And that's all I have for you. So go ahead and rewind if you need to. Email me any questions. And as always, make good choices.